Hey team, good to have you back another week. Hope everyone's doing okay in lockdown and things at the moment. It's a bit of a sad state of affairs across a few different parts of the world, so I hope everyone's doing okay and staying safe. Alright, I'll be kicking things off in a minute. I have angered the live demo gods, I think, this morning, and did some work last night to set up for today, and came in this morning and absolutely have had no luck whatsoever. So we'll see how we go this morning. Yeah, there you can go. You can see what's going on in the virtual machine that I've set up here. Not working real well at all, but that's all right. We'll work our way through. So thanks all for joining again. This is going to be a bit of a developer focused stream today. Sort of focused at people who have done a little bit of maybe a little bit of coding work, a little bit of Arduino work before, interested in getting involved with the Speeduino development, but not really sure where to begin, might be a little bit intimidated by what the code base is, might not have used things like Git before. All of these things can be a little bit scary at first glance. It is a relatively large code base now. It's not something that you can necessarily just look at in 10 minutes and figure out what's going on. So it can be a little bit intimidating, a little bit scary to start off with. So what I'm going to work through today is a couple of different things, all to do with creating a system that you can use that will let you contribute to the Speeduino code in any way you like. So the things I'm roughly going to run through this morning is a really quick overview of what Git is, or what GitHub is in particular, how you can create your own fork on GitHub, which is really simple, how you can then grab the code off your fork, make some changes to it, and I'm going to walk through creating a unit test, and I'm going to talk about what a unit test is and how it relates specifically to hardware and how we do unit testing in hardware. And then we're going to walk through creating a pull request to get that code back into the main Speeduino repo. And I'm going to actually pull that in, so it'll be a real actual demo that makes its way back into the main code. All right, like I said, I've been tempting fate a little bit with the demo stuff that I've set up. So we'll see how we go with that. Fingers crossed we'll have some good luck. Otherwise, we'll muddle our way through. As always, guys, I really do encourage you to fire off questions in chat. That lets me know sort of what you're thinking, what's going on, what maybe things that I'm not making particularly clear. So by all means do that. A few people commented on the last stream that the audio was very low. I've had a bit of a play around with that. Hopefully that might be a little bit better now. But if you're having trouble hearing me at all, please do shout out and I'll see what I can do there. Okay, so I'm going to make a start here in GitHub, and what I've done is just create myself a test account, unsurprisingly called Noisy Mime Test, and I've signed it in over here. It has absolutely nothing on its account. It's a brand new account that I've created on GitHub. There's nothing there whatsoever. And what I'm going to do is head on over to the main Speeduino repo, which is github.com/noisymime/Speeduino, and you'll see the main code base here, all fairly straightforward. What we're going to do is create what's called our own personal fork. Now, a fork is a copy of the code that is yours. It's yours to do with whatever you like, and to make whatever changes you need to do within that. It sits on your own account within GitHub. So at the moment, this version of the code, the official version, sits on my account. But we're going to make the copy here, or the fork, onto our own test account. And we do it simply by hitting this fork button up here. And GitHub will take a few seconds and say, yep, I'm creating a new fork of this. And like it says, only take a few seconds. And it is relatively straightforward to do that. And now we see that we're in the Noisy Mime test account, which is mine, or sorry, the new test account that I've set up. and we've got a version of Speeduino. And we also get a helpful comment here saying that this was forked from noisymime/Speeduino. So we know that this version came from the official one, but this is our own copy, and we know that that's in our own account here. So everything here looks exactly the same as what it did on the other account. That's because it's a straight up direct copy of what we saw on the noisymime account. Anything we do here stays within our own account unless we somehow push it or make a pull request, and I'll talk about those a little bit later, back onto the main repository. So for now, this is our own little safe working environment that we can use to make any changes that we like, and they will only then be reflected on our own version. Oh, well, so many people tuning in this week. That's great to see you all. Okay, so what we want to do is start looking at editing this. Now, what I did was set up a nice clean virtual machine that I was going to use to test all this on, but I fired it up this morning and I got this up on the restart. I was playing with it last night and set everything up and had it all working, and I thought, yep, this will be fine. And I shut it all down and I fired it up this morning, and I've gotten this blue screen on startup. So we might have to just forego this a little bit for now. I was going to walk you through how we install GitHub Desktop on a new machine, how we install VS Code, which is an editor that we can then install what's called PlatformIO into. If we don't get the virtual machine update, that's okay. I'll work through it on my own machine. I suspect this is going to struggle a little bit for whatever reason, but that's okay. I'll walk through it on my own machine, and we can see what's what here. But for the moment, let's get rid of that. Always the way with demos, unfortunately. Oh, thanks so much, Josh. Really appreciate that, man. All right, what I might do is I'm going to show an edit that we're going to make on our own version. And given I can't do it in the virtual machine, I'm just going to do an edit here through GitHub itself. Whilst I wouldn't necessarily recommend editing through GitHub, it does give us an interface to make any file changes that we want. And we can see what differences those make and how the commits work. So what I'm going to do is, what will I do? I might just edit this README file here. So the README file is what gets displayed here at the bottom. And we might just make a quick change to that, and you can see the difference that it makes. So we'll hit edit on that. And I know for a lot of you guys that this is going to be pretty simple stuff. But for those who aren't really familiar with Git, there's a lot of concepts that you have to wrap your head around, and they're not necessarily straightforward. Even if you've used other source code management tools before, and in fact, in some cases, having used more traditional source code management tools, this can actually look more intimidating. But we're just going to add, what do we do? We'll add a quick change here to say, let's put a full stop. We're just going to go test, test, test. And we're going to save that. And now that we see in our README, we've got this test, test, test. Not particularly surprising or earth-shattering there at all. But we see that we now have a new commit. And a commit is when we've made changes to our code and we save them as what's called a commit, which is a nice packaged up block of changes. It can be to one file or it can be to many files that we can use to track the history of things. So in total, there's been 2,290 commits to Speeduino, one commit on our branch, and we can see that our branch, our own personal test version here, is one commit ahead of noisymime master. So we know we've made one commit that's on our version, but that's not gone back into master so far. We can view what that commit looked like, and every commit gets a commit ID, which is one of these big long things here. It usually gets shorter. Oh, there we go. Commit ID. And that's just a programmatic way of identifying this change that was made. We can view the difference of it here. We can say, okay, in the file readme.md, we've gone from having this section here. So in red is the old version, and in green is what the new version is. So we can see that it's got this test. That's a nice, easy way of looking at the changes that we've made, called a difference report. Can I make sure to highlight any differences between Windows, macOS, and Linux as I go? I can. For the most part, there's not really any significant differences here, Michael. The same tools that are available, and I'll get to what tools I would recommend next. These tools are all cross-platform. They all work on multiple systems. They all work on Linux, Mac, and Windows. I do most of my development on a Mac, but do these demonstrations on Windows just because it's an environment that's more comfortable for most people. I'm going to show you two different tools, and these were the tools that I was going to install in the virtual machine had it been working today, which is a little bit frustrating. But the first one is GitHub Desktop. Now, some users might look down their nose at a tool like GitHub Desktop, but basically it's just a nice graphical interface for seeing the code that's on GitHub in your version, making what's called a clone of it, which is how we get the code from GitHub onto our own local PC, and making commits back up onto our repository or onto the master. So this is the first tool that I'd highly recommend you download. You don't have to. There are other ways of doing it. But if you're just getting started, I would suggest GitHub Desktop. The other tool that you need for working with Speeduino, or not need, but very, very strongly recommended, would be a system called PlatformIO. In the past, or traditionally when developing for Arduino, people used the Arduino IDE. We can have a look at that. Which is a tool that Arduino themselves wrote. Let's see if we can find a nice picture of it. And it is an IDE that we can use, but it is incredibly basic. It's not a particularly friendly system to do anything complicated in, but it is a nice, simple system if you're just wanting to write a basic Blink code like this. Once you do get into a more complex project like Speeduino, though, it doesn't really work particularly well. And it's a little bit too simplistic, and it's a little bit basic, and it gets in your way more than it really helps you out. So instead, there's been a tool developed called PlatformIO. And PlatformIO is a way of having an environment set up specifically for hardware development that will work within other IDEs, so other code editors. My preference is to use a tool called VS Code. It took me a long time to come around to VS Code, as it is a Microsoft product, and I was a little bit iffy on VS Code. But honestly, it's a fantastic tool and works and integrates extremely well with PlatformIO, to the point where I would struggle to go back to using anything else now. I'll show you it on this local system. You'll have seen it before if you've seen any of the development streams. But it's a fairly standard looking modern editor. And let me run through what it looks like with PlatformIO. If you have just done a fresh install of VS Code, you'll I won't show that actually. Well, you'll end up with a screen that looks very much like this, obviously without any files open, and these icons down the side, with the exception that this one won't be present. This is the PlatformIO extension. However, all you need to do is go into extensions here, and it'll do a search of of different of the marketplace in VS Code, and just search for PlatformIO. And you'll see this PlatformIO, development environment for embedded IoT, Arduino, embed, all those sorts of things. And all you would have to do is hit install there. I've obviously already got it installed on this PC, and the demo gods weren't smiling upon me today to do it within the VM, but that's okay. The only difference it will make is that once you've installed it, you'll get this icon here, and if you can see them, I might just change the window size a little bit here so you can see them a bit better. You'll see that there's down the bottom this series of icons here. And these are the icons that PlatformIO add for doing things like compiling in the embedded environment, uploading, starting a console, and doing tests. And tests is what we're going to be running through a little bit today. So just catching up with chat here. What happens when you want to make a mistake and want to go back a few commits? So one of the really great things about commits is that they work in a hierarchy. So every commit that we make has a parent commit, which gives us a nice chain, and these end up being trees as people branch out. And there's a lot of terminology around branches and those sorts of things. But the short of it is that we can change things or go back up through the Git history in order to fix mistakes that we've made. So we can roll back a specific commit. If you made other commits since then, it can get a little bit complicated. But in terms of undoing a commit that's already made, or the last commit, it is relatively straightforward to do that. Okay, so I'm not going to cover a lot in the actual firmware today. I've covered that in previous streams, and it's not really the intent of what I wanted to go through today. More, I wanted to talk about the process of simply making a change, making a commit, and then submitting what's called a pull request. So I'll go into it in detail in a little bit as we get towards the end of this cycle. But a pull request is essentially a way of getting the code from your fork or your copy of the Speeduino code that you're making changes to, and getting those changes back into my repository or the master version. It goes through this pull request process where you make all your changes that you need, and then you submit this pull request, which will pop up on my system. And then I can review it and say, okay, what changes have you made? Do I think they're valid? And I'll walk through all this towards the end. So let's get on with making some changes. Now, the changes that I wanted to walk through today are around unit tests. If you've done any sort of development type work before, you're probably familiar with the terminology of unit tests. Unit tests are a way of testing our code to make sure it does what we intend it to do. There's lots of different code tests within when you are coding. You can have a static code analysis type test, which just runs through the code itself and says, oh, okay, this area looks like it might have a problem. It's, you're not following certain conventions or something like that. Or you can have code that actually tests that actually run on a compiled version of the code and make sure it does what it is intended to do. And that's what we're going to be running through today on these unit tests. So unit tests are made a little bit more complicated in an embedded environment because we have to test the code on an actual Arduino itself. There's not a lot of point in looking at the code, or there is some point, but it's not an extensive test to only run that code on your PC and see if you get the right outcome back from it. There can be differences in the architecture. There's differences in the way memory might get mapped. And you can't always be certain that the test that you're running locally on your PC is what you're going to get when you actually run it on an Arduino. I'm not sure how to say your name there, but thank you so much for the donation. I really appreciate that. Thankfully, One of the great things about PlatformIO is that it does have a unit testing framework built into it. Now, it was a little bit complicated to set up, but once it is set up, it runs really smoothly. And I would urge anybody who's done any work with Speeduino before or is looking to get into it to have a look at unit tests, because they are absolutely becoming more and more critical in the code base, particularly as we get more contributors on board, and are going to be something that I want to keep expanding on. I hope others will look at expanding on, and will become a really critical part of validating that the code we're working on is good. So let's have a look at a unit test. Down here in the tests folder. And I'll say at the moment that the unit tests that are set up within Speeduino, whilst covering a couple of the more critical areas, are far from complete. That there's a lot of gaps in the coverage of those tests that I'm slowly but surely piecing in, but is a really perfect area if someone wants to sort of dip their toe in the water for getting involved with Speeduino, if you want to create a unit test or have a play around with them. So let's have a look at the miscellaneous tests, and we'll have a look at the table one just as a starting point. So within Speeduino, there's a section of code that deals with tables, 2D tables and 3D tables. This set of unit tests is designed to check that the outcome from performing a lookup of those tables is what we would expect to see. So pretty straightforward in terms of concept, but not necessarily straightforward in terms of how it's actually doing it. This unit test is a little bit more of a complex one, but what it's actually testing is fairly straightforward and fairly simple to understand. So if you can see here, there's a representation of a fuel map written out in pretty ASCII. Hopefully everyone can see that. Let's make it a little bit bigger just in case. So we would have, our load axis down the left-hand side, we'd have our RPMs along the bottom, and we'd have our fuel map spelled out in the middle. I've written this out here simply because this is what the map looks like that I'm going to be testing with. We have to create a simulated environment when we create a unit test, and this is the simulated map that I'm going to be working with. So set up the fuel table with some sane values for testing. Table is set up per the below. You can see all this getting loaded in here. It's more complex than you need to worry about, but all it's doing, all this rather large section of code here is doing, is loading this table in to fuel table 1. We've then got, how many have we got? 7 tests here that I've set up to run through it. And we're going to look up or perform a lookup of the table that's at 50% of the way between 2 cells. So if we were doing a lookup of this fuel table, it would be, say, where the RPM is not 2000, not 2500, but 2250, right in the middle of these 2 numbers. And in fact, let's get the actual numbers that we're looking at. Oh, there we go. I did pick 2250. So we're going to say in our particular test that the test RPM that we'll be looking up is 2250, and the fuel load that we're going to be looking up is 53. So if we look at our table up here, we can see that at 2250 RPM, it'll be exactly halfway between these 2 columns. And what did I say? 53. 53 on the load table, which is load axis, sorry, which is exactly halfway between 56 and 50. So on the lookup, we're looking at these 4 cells here, the 71, 72, 66, and 68. And we should be smack bang in the middle of that to get a result. And that's what we would expect to come out of our fuel table under those given scenarios. So we set up our fuel table. We do an initialize. We set up the fuel table, which all it does is load these values in. We set the RPM. We set the expected load. We do a lookup on that 3D table. We say, here's the fuel table, here's the fuel load, here's the RPM, and we get a result. And we're going to make an assertion in our test. And an assertion is something that we're saying is going to be true. We whatever goes on in here, and in this case it's an assertion that two things are equal, that's what our test is going to look for. So in this case we're going to look at our return value from the table, and we're going to say, is it 69? If that's true, then the test is passed. If it's false, then we know that we've failed. Something in our lookup code hasn't worked, because the expected return value here, interpolated between these four cells, this one, this one, this one, and this one, is 69. That's a really quick overview of how a unit test works. You know, we create a scenario, and we give it a result that we're expecting, and then we check the actual result that we get on the system itself versus that expected result. And we can run all these things very, very quickly, and what it does is means that we don't, when we make a change on our table lookup code, for example, whilst we obviously need to test it ourselves and make sure it's working, we can be confident that we've checked other scenarios that we might not have thought of, and to make sure that they're working just as well. Now, why do we need so many tests? And that's the thing. With unit tests, you need to cover a lot of different scenarios. Now, in this case, this was testing a scenario where the RPM and the load were exactly 50% between two of the points on the table. We've got another test here called exact one axis. So, tests a lookup that exactly matches on the x-axis and is 50% of the way between cells on the y-axis. So in this case, we've got a load of 48 and an RPM of 2500. So if we look up here, we actually have an RPM cell that's exactly 2500. So this is something of an edge case, but it's something that we need to test. And we say we've got a load of 48, which is halfway between these two values on the load axis. So this column here, 2500 RPM, and halfway between the 68 and the 62 should give us a result of 65. If my head has woken up this morning and I'm looking at the right rows, which I think I am. And so if we look at this test, we'll see a comparison. We'll do that lookup, and we'll say the assertion is here that the result that gets returned is 65. We know that if that proves true, that this particular case is likely to work in all scenarios that match that scenario. All right, we then test a bunch of different things. So exactly matching on two axes. Test a lookup that exactly matches on both the x and y axis. An unlikely scenario, but this is a good edge case that we do need to test. Over max x. So test a lookup where the RPM exceeds the highest value in the table. The y value is a 50% match. So this would be a case where the RPM might be 8,000. Now 8,000 is beyond the end of our fill map in this case. So how do we handle that? How does the lookup code handle it? And are we getting the response back that we would expect from the lookup code? Whew, okay. All of that's a long way of saying that unit tests are really bloody useful, and having them covering as much of your code base as possible is something that we really strive for, and something that I need to put more time into myself a little bit, but would really strongly encourage other people to look at if you want to start making a contribution that will be extremely welcomed into the main repository. B, you can do without worrying about breaking anything else, because there's nothing you can do in a unit test that's going to break the firmware at all. And 3 is a fairly simple way, relatively speaking, of familiarizing yourself with the Speeduino code base that you can use to sort of dip your toe in the water before really ripping into the firmware itself and making functionality changes or bug fixes or anything like that. All right, let me catch up with chat for a minute here. Big Cheese, will these unit tests be saved and run as a regression test suite on future releases? Okay, so this brings me to my next point. Once you've got these unit tests in place, you can simply click this button down here, which gives you all the different compile and test options within PlatformIO. So you can just build, you can upload, or you can test in this case. So what I'm going to do is run a test. Now I have an Arduino plugged into this machine at the moment. Just bring that up. And you can see that it's going to build the firmware. There's a few different warnings at the moment that I need to clean up in this particular development firmware. It builds the entirety of the firmware here. So obviously the whole firmware has to get built and uploaded to the Arduino. So it'll do that now. And instead though of, in this particular test mode, instead of just running the firmware as it would normally, it will boot into a test mode on the Arduino, and it will run those tests that we've just been running through, or that one amongst many. So this test function is something that I would urge all developers on Speeduino to look at. It's just writing the firmware up to the Arduino at the moment, and run fairly regularly. However, the good news is that this unit testing is now part of the, or has been for quite some time, part of the Arduino integration environment. So you can see we've uploaded now, and it's going to run all those tests, and all the tests that we have, including the table lookup ones, are listed as passing. What I'm going to do in the background, whilst I'm chatting away here, is I'm going to make a change to one of these. And I'm going to say, oh, instead of 69, what happens if the result is 71? So I'll send that up again. And whilst that's working in the background, I'll talk about the Speeduino build environment. When a pull request or any change, in fact, is made to the Speeduino master code, there's some automation that happens in the background where, amongst other things, all of these unit tests are run and are loaded onto an Arduino that sits on my workbench, my test bench. The code that you've committed, whether it be via a pull request or whether it be something that I've committed directly onto the master firmware, that code will get uploaded automatically onto that board after the commit is made, and these unit tests will get run. If any of the unit tests fail on that automated testing, it pops up a message for me in Slack, and I can have a look at the code and see what's going on. So I'm not sure if that answers your question there, Big Cheese. But yeah, from my understanding of what you've asked, yes, these unit tests are saved and they get run every single time a commit is made onto the master branch. Okay, so now we've got our tests and we can see that this one has failed. We expected 69 and it was 71. I've actually got my code around backwards here, haven't I? So these should actually be the other way around. The expected value should be here. We should have the 71 here and the temp VA here, but that's okay. But we can see that in any case, the value that we were testing against did not match the result from the lookup table, and hence that test is said to have failed. We'll change that one back. Okay, so that's a good example of a unit test. Now, I've got a couple that I've made that we're going to run through today, and are actually new additions. They're not on the Speeduino firmware today, and they're not part of the testing framework yet, but we're going to make a commit, and we'll walk through how that works. Just catching up with code here. Yeah, it's kind of a semi-automated HIL. Yeah, it's not quite full HIL. So for those who are not familiar with the terminology, HIL is hardware in loop in the way of testing full running code. what it's not testing here is an actual running system, so that the machine or the Arduino that it gets loaded up to automatically on my bench doesn't have a stim attached to it. So it's not testing, say, what happens if we actually feed a 2000 RPM signal into it. We're simply simulating a 2000 RPM environment in code rather than plugging an input into it. So the intent, I guess, here isn't to test the hardware inputs and making sure they're okay. It's to purely test that a particular piece of code has done exactly what we want it to. And that's sort of what I'm going to cover in a bit more detail now. So I'm going to show you some tests here for DFCO, which is deceleration fuel cutoff. So this is the functionality within Speeduino that when you're cruising along at, let's say 60 mile an hour, and you need to start slowing down for an intersection or something, and you take your foot completely off the throttle, you, to save a little bit of fuel, have DFCO kick in. So that means that whilst you're cruising along at, let's say 3000 RPM, and you take your foot completely off the throttle, the fuel signal will be cut completely out. This saves a little bit of fuel, and then the fuel can kick back in once the engine actually needs to start idling again, rather than having the car spin the engine around. Fairly straightforward piece of code, but it's a really good example of why even a straightforward bit of code can get a little bit complex, and can get, or can be something that we need to test. So let's have a look at what the DFCO code is, and it's this section of code here. So this is in the corrections file. I'll walk through it, but it is relatively straightforward in terms of what it's doing. Hello from Austria, not Australia. Yeah, that comes up so often. Okay, so correction DFCO. This is the function that we run to see whether DFCO should be turned on or off. Returns true if deceleration fuel cutoff should be on, false if it's off. Fairly straightforward. There's a couple of different things that we need to understand, though, because DFCO is a little bit more complex than it looks at first glance. We start off by setting a return value here, and we set it to false. So the assumption here is that DFCO is not turned on. The absolute first check is that the setting for DFCO is actually going to be enabled. In the background here, I might actually just fire up Tuner Studio, and you can see what some of these options are. If the actual feature is turned off in the tune, we don't want to be ever returning that this should be true. The next is to check whether DFCO is already active. Is it already on and running? If it is already on and running, we're going to check that it still should be running, or whether we should be turning it off. If it's not already running, and I will cover all these. I realize I'm flicking through them fairly quickly, and I will cover them more in a little bit more detail as we go through. But if it's not already running, we're going to check a few different things. We're going to check whether the coolant is below our minimum threshold, and don't worry too much about this temperature offset. This is simply part of how we communicate back with Tuner Studio. We're going to check that the RPM is above our RPM point plus a hysteresis amount. And we're going to check finally that the TPS reading is below our TPS threshold. Now, all of these relate to settings in Tuner Studio that a person can tune. So let's have a quick look at that. Acceleration and enrichment. Down in this bottom section, we have the deceleration fuel cutoff settings. So the first one is the one I was talking about here. Is it on or off? Right, it should never be kicking in if it's off. And that was our first test in the code here, was whether this feature is actually turned on or off. If it's set to 0, so that feature is off, we're going to fall straight out to the bottom and we're going to return false. If it's on, however, we've got a few different things. We've got our TPS threshold, and I won't go into detail about what this feature is too much about what all these options are. But we've got a minimum temperature, so the DFCO feature won't operate while the engine is still warming up. So we'd normally set that to 60 degrees or something like that. A cutoff delay. So this is a delay in seconds before the DFCO will kick in. This can just help when you just slip your foot on the throttle, or just back off quickly, or there might even be a little bit of noise on your throttle. So to say, okay, yes, the DFCO will turn on, but it'll only turn on after, let's say, 1 second. So after your foot has been off the throttle for a whole second, this feature will turn on. The cutoff RPM, so DFCO will only function above a certain RPM whilst you're slowing down. Once you get back below that RPM, the injectors will kick back in. And finally, what the hysteresis is. So this is if you're not familiar with hysteresis, this is a way of making sure that we don't get things turning on and off rapidly. So we say when you're above 1500, this will turn on, but it won't turn off, for example, until you get below 1300 now. So 1500 minus 200. And it's just a way of, if your RPM is sitting at 1501 and is fluctuating between 1501 and 1498, you're going to have your fuel quickly turning on and off. We don't want that, leads to bad things. So we have this hysteresis. So these are all the settings that we have as part of our decision making for deceleration fuel cutoff. And these are all the things, believe it or not, even for a simple feature as simple as DFCO, that we need to test. I'm just keeping half an eye on time because I'm waffling far more than I expected I would today. So all of these, every single one of these is something that we need to be checking for. Now, in our unit tests, I've just written these just last night. So I've created a setup function, which just sets a bunch of defaults for our corrections. We make sure that the feature is turned on. We're going to set a simulated RPM of 4000 for the moment, which is plenty high enough. We're going to set our simulated TPS to be 0, and we're going to set our simulated coolant value to be 80 degrees. In terms of so that these are the simulated settings. Anything that's on a current status is a status in a simulated environment, or what the firmware actually believes is the current case. Anything that starts with a config page is something that comes out of the tune itself from Tuner Studio. So this one here, DFCO enabled, relates direct, or is a direct representation in the code of that on-off field that we saw. The other settings that we're going to force are, we're going to say that the DFCO RPM should be on 150. Now, this is because the value that gets sent from Tuner Studio is actually divided by 10. So this value here of 150 actually represents 1500 RPM. The TPS threshold is going to be 1, so we're going to say any TPS less than 1 and DFCO will be active. Now we know that our simulated TPS is 0, so that should pass. We're going to set our hysteresis to 50 RPM, our minimum coolant to 40. Now this is actually offset back to 0, but again, don't worry too much about that for now. And we're going to set a delay to 10. Now again, this is actually divided by 10, so the delay in this case is actually only 0.1 of a second. So those are just going to be some basic setup or basic configurations that we'll use on a few of these tests. And because we're using it on just about all of them, I've just pulled them out into their own little function. So this isn't a test itself, it's just a utility function that we're going to use to set things up. Yeah, so that's an important distinction here. We're not testing the calibration here. We're not testing any of that. We're testing that the code is doing what we expect it to do under certain conditions. And we're going to create what those conditions are, and then we're going to test against those conditions. So the first and most absolutely basic test is that under ideal conditions, and all the conditions that we would expect, DFCO actually goes active. So that's what these conditions are here. They set us up in a position where DFCO will be active if all of these things are true. The RPM is above our minimum RPM, 4000 above 1500. Our TPS is 0, which is below our threshold of 1. Our coolant is 80, which is above our minimum coolant value. everything is set up so that it will turn on. So this is the most basic test we can have to test that DFCO will come on. And all we do is we set those variables up and we run the correction DFCO function, which is this one here in the firmware. And it'll run through and it'll check all those conditions. And if the whole thing has worked, then it will return true. If not, it will return false. And all we're going to do is assert that the value returned from it should be true. So in this case, we're saying that given all of these conditions, this function should return true, which means DFCO is turned on. That's a really basic function, and but it is the starting point that we need to be testing, that we can actually get this turned on. You'd be amazed how really basic stuff like this can still be a little bit complex to test, but it's really great at making you think through all of the different variables that are going into something and how and why it's not turning on. When I was writing this test last night, I spent like 15 minutes because the corrections kept not turning on. And it was driving me nuts. I couldn't figure out why it wasn't turning on. And it turned out to be that the time factor involved here wasn't being set right. Now this is why I'm doing this little bit of code here that already runs the function once, because you'll see that this section here is what checks that we've had enough of a delay before turning the feature on. The first time this function gets run, DFCO start time, or DFCO start, will have been set to 0. And so we then set the DFCO start time to be what the current time is now. And that says, okay, when this function runs again, we'll know whether there's been enough of a delay after all of these conditions were met to start DFCO. But the resulting, or the upshot of that is that the very first time you run this function, it's never ever going to be turned on. Right? It will always return false, because the first time you run it is the first time all of these conditions will have been set to true, but the delay hasn't happened yet. So we know that we have to run it at least one more time before we can get a value of true, because otherwise we can't know if that delay has happened yet. And in my half awake state last night, it took me a good 15 minutes to twig to that. But it's really good at getting your head in the right space and making sure you're actually doing what you think you're doing. So that's why we run the function once here, to set up the delay check, and then we run it again to see whether it's actually working. Okay, so it's not just enough to test that our code is working under certain conditions or under ideal conditions. We actually have to break it. We have to make sure that it will turn off after certain conditions are met as well. So that's what the rest of these tests are around. Test corrections, DFCO, off, RPM. So test that DFCO comes on and then goes off when the RPM drops below a certain threshold. We don't want to just test that the RPM is making this turn off, because the default case for this function is already off. We need to test that we can turn the function on and then turn it back off again. So that's a much more comprehensive test, and it won't lead to false positives than if we just tested if it was off, because the default condition for this function is already turned to off. So anything could be going wrong and it will be turning to off. We want to test that we can turn it on, change just one variable, run it again, and make sure it's turned off now. So we do the setup function again. We make sure that the function has turned on, and we expect it to be true. And we're going to do two assertions here to say, yes, it's turned on. We're going to change just one thing, not lots of things, just one, which is the RPM. And we're going to set our current status RPM to be 1,000, which is below the 1,500 threshold that we set up. And then we're going to test the function again and make sure that instead of returning true, we're now asserting that it should return false. With unit tests, the hint is in the name. You want to be testing one unit of thing, one little piece of code. You don't want to be testing, you don't want to have a lot of these assertions in a single test. That shows you that you're not testing one thing, you're testing many things. We just want to be testing one scenario and one scenario only. It makes for more code to write to do these tests, but it's the only way we can be clear about what our tests are. Otherwise, we get a test that fails, and we have to look through all our code and say, oh, why did it fail? Well, one of these 25 different cases has failed. We don't know why, because we bundle all of the cases into a single test, and we don't want that. Okay, so I've then got a bunch of others. I do the same thing for TPS, right? Test that DFC comes on and then goes off when the TPS goes above the required threshold, i.e. we're not off throttle anymore. So we do the same thing. We do our setup function. We assert that DFCO has come on. We change one variable and one variable only, in this case the TPS. We make TPS equal to 10, which is above our threshold. And again, we check that it's false. And then we check the delay, right? We check that it won't come on. That's actually not a very well written test, actually. But you can see that these are fairly clear cut in what they're doing. They're making one little change and making sure that change has had the desired outcome. We then run these tests down below. So we're going to run the default one, the RPM one, the TPS one, and a delay one. And hopefully we get results of true, which we can see in the cases that we looked at before. Where are we? DFCO. That these did indeed all pass. So happy days. We've got all our tests passing. So you've written these tests. What do we do with them? How do we get them back to the Speeduino code itself? So given that our VM was a complete and utter failure, what I'm going to do is simply copy all of this code that I wrote. And I'm going to jump back into GitHub. And I'm going to have a look at my code, and I'm going to just just paste this code in as a new commit. Now, normally you would do this through GitHub Desktop. You'd make your commits. But in this case, because we're a little bit broken, actually, I can show you how that would work. So if I were to bring up GitHub Desktop here for this local version, you can see that I've made changes here. 3 different files to the corrections file, which I've obviously just put an empty line into, and into the corrections testing file. This is all the code that we just added. And the change that I made into the test code. But we really only need to worry about these changes here into our corrections testing. Normally then you'd simply say added unit tests for DFCO, and you'd make a commit, and then you'd then push that commit up. I'm not going to do it here because this is working on my master one, and I want to show you how a pull request works. So let's do that. We'll go into this file. I'll edit it. So let me catch up on chat here for a minute. Yeah, so Alexander's comment there, you're not testing the calibration tune here, but you're testing the code itself. Yep, exactly right. Yep, cool. Okay, so what we're going to do is, this was what the code looked like in master. Right? We just had an empty function for corrections DFCO. That's the new code that we've written. So we're going to get rid of that. And we're going to paste in the new code that we wrote. We also just need to call this function. So I've just got one little function down the bottom, by the way, that just runs through all of the DFCO tests. Just make life a little bit neater. Then up the top of the file, just add another little line for test corrections, DFCO. So that should, I think, be all we need. Let me just check in GitHub desktop again. We can see all of the changes that we made. We're just going to compare these. So you can see that we removed that line, and that's exactly what I just did. I added this line up the top, and I added this whole big chunk of code that I just pasted. So that's all we've done. Now, keep in mind that I'm working on my Noisy Mime test branch here, not the actual master. So I'm going to make a commit saying added DFCO unit test, and commit that. Cool, and we have a commit. If we jump back into this now, we can see that this branch is 2 commits ahead of Noisy Mime master. All right, so we've got code in our version or in our fork that's not on, not yet back in the Speeduino master repo. How do we get it back in there? Well, we create a thing called a pull request. So I'm going to go new pull request. Okay, and we're going to say the base repository here is Noisy Mime Speeduino, which is the master. And we're going to pull our code from Noisy Mime test back into that master, or we're going to request it at any rate. We can see that we've made 2 changes. We made this one to add the test. We're not going to want that in the master code, but we're going to push it through on the pull request anyway. And we made this big change here in the unit testing, which is the one we actually want. So what are we going to do? We're going to go create a pull request. I'm going to say added unit test for DFCO. Now, this is where I want to have a little bit of a rant myself. If you want your code to get pulled into Speeduino master repo, there's a couple of guidelines you should really follow. And the first is that you need to make your pull requests what's called atomic. They should do one thing and one thing only. If the pull request that you're making adds 20 new features, edits 30 different files, and is 1,000 lines of changes, it's probably going to get rejected, right? Because it's simply too complicated for me to review. And I'll be brutally honest, is probably going to introduce bugs. You need to break it down to be as small as possible. The smaller a pull request is, and the more limited it is in its scope, the more likely it is to get accepted. In this case, we're doing one little thing. We're adding 4 tests. That's all we're doing. I didn't change the firmware code itself and add a test, right? That would be bad. I've just added tests. If you want to change the firmware and add a test, that's fine. I have no problems with it. But you need to make that 2 different pull requests. That way I can clearly delineate what you're actually trying to do. And that's a bit of a rant, but there's been a little bit of topic or a bit of talk lately about pull requests that are sitting there and not getting in, and that's fully on me. I don't get to all of those as quickly as sometimes people would like, but it's also down to people submitting pull requests that are doing multiple things. They're horrendously complicated, and they're probably not going to get pulled in. They need to be broken down to just do one little thing. And you can submit 5 different pull requests, each with one little thing, but it makes it much clearer what they're doing, or what you're intending to do, and it makes it much simpler for me to then review. Okay, so we're going to create that pull request there. And we're done. Oh, okay, pull request created. Terrific. Now, if I'm on my test account here, but let me jump back into my main account. And if I look at pull requests now, I'm going to see add unit test for DFCO. The world works. It was created 21 seconds ago by Noisy Mime test. And if I jump in and have a look at that, I can see it's got 2 commits in it. And I can see that there's 2 files changed. And the absolute first thing I do when I get a pull request through is look at the files changed. If this number is like 15, I can tell immediately that either this is going to be a big pull request that it touches a lot of files because it has to touch a lot of files, or because it's doing something it shouldn't be and is probably going to get rejected. Is Speeduino my full-time job, or do I have another job? No, Speeduino is just what I work on outside of my job. I have a normal full-time job as well. I would, at some point down the track, would love to make Speeduino my full-time gig. I really would. But I need to make it a viable prospect first. So that means not only selling boards, but just making sure that the time I put into Speeduino's development can be recovered somehow. All right, so I see two things here. I see all these unit tests. I go, whoa, the unit tests are good. I like those. I really want to have those committed. But what the heck is he doing here? Right? Why has he added test? I don't like that. In this case, I might speak to the person who submitted the pull request and go, what were you doing here? And they might go, oh, sorry, I did that while I was testing. I should have pulled that out. I'm really sorry. They can either go back and create another commit that will remove that, or I can simply say, okay, that's fine. All I'm going to do is jump in and I'll remove it for you. So I can now edit this pull request as well. I can commit that. Now we can see that that's back to the one change here is that I put a full stop on the end that I forgot to get rid of, but that's fine. And we've added all this code. Happy days. So I'm going to be pretty happy with that now. And I'm going to look at it and go, that's fine. It's all neat. It has no conflicts with the base branch, which is good. I'm going to merge that. And this code, as soon as I hit merge now, has become part of the main repo. We're now in, we're actually in the master firmware. And what I'm going to do is just show you what the automated checks look like that's going on. Oops, if I can type. So it uses a testing system called Travis in the background. Okay, and you can see that if I've logged on to Travis, already it's picked up that there was a pull request for added unit tests for DFCO, and it started the test. If we watch this, you can see that on a remote system somewhere, it's now building the firmware. It's going to build it for every platform. It's going to build it for the Mega. It's going to build it for the Teensy 3.5. It's going to build it for the Teensy 4.1. Every single platform. So now we're building for Teensy. All of these checks happen with every commit into the main repository. So if you've made a change to the code that works on the Mega 2560, but it might break Teensy, we'll know that immediately. Or we'll know that as soon as the test's finish. So now we're going to build for Teensy 41. And we can see all of these worked, right? Success for that, success here, success. So that was all good. We've passed all of those. And it will upload that firmware to my server. Where's the unit testing here? Somewhere there should be unit testing taking place here. I think, if I'm remembering where I put it. No, not in there. My memory must have failed where I set up that test. That there is actually another set of tests that get performed on an Azure environment, and I perhaps put the unit test in there, and I forgot about it. That's all right though. It will perform those tests, and if they pass, then all is good. If they fail, it'll pop up a message in Slack for me. I think it's happening down there. Oh, here we go. Okay. Sorry. Okay, it was actually testing the pull request as it came in, and the pull requests themselves don't get the unit testing taking place. The unit testing only happens when a commit is made to master. There's a couple of different reasons for that, but that's the situation. So sorry, I threw the wrong info out there. If we watch this again, okay, now we can see that it's built the unit tests. Now it's uploading to the Arduino that's sitting on my test bench in the other room. So this is actually happening from a server, wherever the Travis servers happen to sit. uploading remotely to my test 2560. So this is not the one that's plugged into my local machine or anything like that. This is uploading to my remote board plugged in onto a server on my workbench. And once it finishes uploading, it'll run these tests. And there we go. We can see that our DFCO tests have now been included, and not only included, but they've passed. And that's another good check, because it means that not only did they pass on our local system here, but they actually passed when they ran on the remote system, which is another good validation step. And everything looks green. Everything's passed. Everything's happy. The new firmware build is uploaded to the server. So this is when, if you've ever used Speeduino and you pick your firmware version, you can actually scroll down right to the bottom and get master. This is where that actually comes from. So once it's finished this build, it uploads it to the Speeduino server and lets you download it from there. So that's the sort of what's going on in the background with all of the testing. It was really painful to set all of this up. It took quite a long time, but now that it's all in place, it just runs, and it runs smoothly, and everything's happy days. But it's all of this sort of background infrastructure that really helps in the development of Speeduino, and means that I can have a little bit more confidence in things getting committed. But like I said right back at the start, the unit testing coverage is not necessarily where it needs to be in Speeduino. It will be expanded over time, and I would absolutely love for people to submit some more unit tests as they go through. But every unit test helps test something, and helps increase the coverage that we have, and gives a little bit more confidence to pull requests and any changes that we make, that they're not breaking something that we didn't intend them to be touching or breaking. Oh, okay, take a bit of a breath. That covers most of what I sort of wanted to run through today. I apologize profusely that my my virtual machine test or virtual machine didn't show you what I wanted to in terms of cloning cloning our fork and setting up PlatformIO from scratch. But unfortunately, the demo gods weren't smiling upon me today. But otherwise, I've run through what I wanted to run through in terms of making a change to your local fork, what unit tests are, why they're valuable, why they're a good place to start, submitting a pull request up for our changes, the process that it goes through to get reviewed and then merged in, and then the tests actually running in the background. So those tests, by the way, will now run every single time anybody makes a commit to master. So those will happen from now until eternity in terms of the Speeduino code. Wow, how are we going for time? We're about 10 past, which is good. That's about the time I wanted to sort of aim for. Does anyone have any more questions that they want to fire off around anything at all that I've touched upon there today? Was that a helpful session? Did you get anything out of it? Was it enjoyable? I hope it was of some use to folks. Are you planning on doing a stream of the subject of the code to electronics and how it works? That's an interesting question. I can. I'm more than happy to do a stream on just about anything that anyone wants if there's value. I guess that question, Matt, is more around how what we're doing in the code actually relates to what happens on the Arduino. Is that right? If so, I can talk a little bit about that. It sort of touches upon the basics of Arduino coding rather than anything necessarily that Speeduino is doing. But I can certainly do a basics class of Arduino type stuff. Well, not class is the wrong word. It's a silly word for me to use. But yeah, I can certainly run a stream on that if you want. Cool. All right, guys. I hope you've enjoyed that. I know I had fun other than the woes with the virtual machine. But I might sign off there for today. If there's anything else you do want to hear me from, by all means, drop a comment on YouTube. By the way, that this is obviously available for replay if you want to go through and watch it. Please do drop a comment. I'm always looking for things to run sessions on. But otherwise, hope you all have a terrific week.